Evelyn. We're learning about Newton's 3 laws of motion.
Newton's laws of motion describe the relationship between forces and the motion of an object. These laws of motion will help you understand why you and the object around you move in a certain way.
Newton's first law of motion states that an object at rest remains at rest and an object in motion remains in motion and at a constant speed and in a straight line unless acted upon by an unbalanced force.
That's kind of hard to understand, right?
Well, imagine.
Becca and the skateboard were moving at a constant speed and in a straight line until the outside force, friction from her shoes against the ground, caused Becca and the skateboard to stop moving. When Evelyn was on the skateboard, the outside unbalanced force of friction between the wheels and the ground caused Evelyn and the skateboard to eventually come to a stop.
The motion of an object will not change unless the object is acted upon by an unbalanced force.
When Becca and Evelyn came to a stop, the unbalanced force is friction.
Friction is the force that opposes motion between two surfaces that are in contact, and the friction between the ground and the skateboard's wheels causes the skateboard to eventually stop.
Evelyn and Becca were on a drive through the city at a constant rate and in the same direction until they had to come to an abrupt stop because the little old lady was crossing the street.
Their bodies wanted to continue going in a straight line at the same speed as they were before, but the outside force of the seatbelt caused them to stop moving. Inertia is a property of matter.
Just kidding, inertia is a property of matter, but it is also the tendency of all objects to resist any change in motion.
Because of inertia, Evelyn and Rebecca moved forward even though the car came to a stop.
The seat belts were the outside force that stopped Evelyn and Rebecca from continuing to move forward at the rate of the car and their bodies were previously traveling at.
Newton's second law states that the acceleration of an object depends on the mass of the object and the amount of force applied.
The equation, force equals mass times acceleration, F equals ma, is used to find the amount of force needed to push an object of a certain mass at a certain acceleration. Here are some examples to help you better understand Newton's second law of motion.
When Rebecca pushes the shopping cart that is empty, she uses less force than Evelyn, who pushes the shopping cart with something in it.
The formula F equals ma is used to find how much force is needed to move an object with a certain amount of mass at a certain acceleration.
In order to give the loaded cart the same acceleration as the empty cart, Evelyn would need to exert a greater force on the cart she is pushing than the amount of force Rebecca is on her cart because the mass of Evelyn's cart is greater.
Now it's time for the last of Newton's laws of motion. The third law of motion by Sir Isaac Newton states that for every action there's an equal and opposite reaction.
This means that if object A pushes on object B, then object B pushes on A with the same amount of force, but in the opposite direction.
Evelyn pushes on Rebecca's hands, and Rebecca's hands push back on Evelyn with the same amount of force, and they both fall in the opposite direction that they pushed.
The action force is Evelyn's push against Rebecca's hand, and the reaction force is Rebecca's hands pushing against Evelyn's hands with the same amount of force.
The reaction force causes both girls to fall in the opposite direction.
Newton's second law.
Thanks for watching. See you next time on Science with Revelyn.